Hello, welcome to the webinar, Automating Hazardous Area Sensor Data for Improved Process Safety and Efficiency, brought to you by Aegex Technologies and Microsoft, and OSIsoft, excuse me. Before we begin, I'd like to direct your attention to the control panel on your screen. You will see a section called Questions. Anytime during the presentation, feel free to write in your questions, and we will take 5 minutes or so at the end to answer those. If we don't get to your question during that Q&A time, we'll respond to you directly via email. Also, there will be a poll question that pops up during the presentation. So please just make a selection and answer the poll that you see on the screen. Finally, following this webinar, you'll receive a follow-up email that will contain a short survey. Please fill out that survey and submit it so we can get some feedback from you. And as always, feel free to contact Aegex with any questions or other needs. So without further ado, I'd like to introduce our speakers. Our guest today is John Marriott, Partner Manager for OSIsoft. He will be presenting along with Keven Smith, Aegex's Director of Strategic Development. First, each speaker will give some quick background on their company's solutions, and then they will discuss some common use cases in which those solutions can work together to provide even more data insight into hazardous area operations and to help organizations better predict potential issues before they become problems or mitigate problems before they become catastrophes. So I'll go ahead and turn it over to Keven Smith of Aegex to get us started. Keven?
Thanks, Lee. So one way to look at process control and predictive maintenance is with the Swiss cheese model of process safety, which explains how specific combinations of factors can line up to cause an accident. The Swiss cheese model was developed by James Reason in 1990. It's the most widely used accidental analysis model. It depicts the concept of safety in layers, with the holes in those layers corresponding to deficiencies due to latent errors like organizational errors, environmental errors, etc. So errors and issues or holes can be happening all over, but when the holes are in alignment, accidents happen. So the goal then is to gain better context and see the confluence of issues that are mounting up before serious problems occur. So in this webinar, we'll be exploring how Aegex Technologies' NexVu IoT Solution and OSIsoft's PI system together can essentially plug the holes to mitigate potential problems in oil and gas and other hazardous area environments. The first step to addressing potential operational issues is collecting contextual data about the environment to see what's normal or what's unusual, what's potentially problematic in order to assess the situation. So the Aegex NexVu IoT solution can help do that in hazardous environments. Many of you are probably already familiar with NexVu, but for those of you who are not, NexVu, it's an open, intrinsically safe sensor system. It's interoperable with various communication protocols, cloud infrastructures, communication devices like Aegex 10 intrinsically safe tablet or other mobile devices, and a variety of applications for field services and asset management, including the PI system. So NexVu's modular design, which permits attaching up to 32 sensors simultaneously to an endpoint, battery, and Wi-Fi radio, enables you to capture thousands of combinations of data, more than 60,000 permutations, to get a next level view into hazardous area operations that might not be seen with individual sensors. This plug-and-play design, it lets you add nodes as needed to monitor more than 40 different gases and environmental conditions. It can be set up in minutes just by snapping the interlocking nodes together, and because it's battery operated, you can install it or temporarily place anywhere in a hazardous environment according to how the chemicals or gases you're measuring rise or fall. I should also mention that the NexVu nodes, they come already to go right out of the box. They're pre-programmed and ready to start reporting immediately. They're automatically identified by a user's process automation, asset management, or rounds management application, including the PI system. So NexVu, it currently operates on Wi-Fi connectivity. LTE, Wi-Fi over LoRa, Narrowband IoT, and Li-Fi are also all in development now. So NexVu can also connect legacy sensors and equipment. effectively making legacy equipment into a cloud-connected smart equipment or smart sensors that can be monitored in conjunction with other factors that NexVu is monitoring. So NexVu is collecting all types of contextual data to feed into an analytics platform that can help line up the holes to determine where or when certain issues might combine to cause a problem. That's where OSIsoft's Pi system comes in. I'll turn it over to you, John, to explain. John?
Thank you, Kevin. So OSIsoft is a company that's been around since about 1980. The Pi system was started in 1985. It's installed in about 140 countries, 21,000 or more sites, and our customers have licensed approximately 2 billion data streams from us. So that would represent a pressure, a temperature, a flow, a pH, or whatever other sensor value that's being collected from a control, typically from a control and monitoring system. We've been around a long time, and once our customers are customers, they tend to stay with us, as evidenced by 24 out of our 25 first customers, going back to the 80s, are still customers with us today. The OSIsoft serves customers that tend to be in heavy critical operations. So you can see from this display, big process industries, and they tend to have engineers on site. And if you can give those engineers data and the tools to look at that data, then they tend to just want more. We're also expanding into other industries. Something that's common to all of our customers is they've got facilities to monitor and transportation. We're also in discrete manufacturing and food and beverage as growth areas. The way that our customers use the Pi system, from having been polled by us several years ago, and we categorize their uses into these 6 categories of asset health. So people use data from machinery to do condition-based maintenance, predictive maintenance, and making asset health indices and other indicators of how to maintain systems and improve reliability. Energy efficiency, that could be as energy as an input to a process, or for facilities like university campuses, office buildings, data centers. Energy is one of the biggest costs they've got for running their operations. Process optimization is an area that the Pi system is usually adopted for first. People improve their yields, stabilize their processes, and just generally do process improvements. Quality, people monitor their quality with the Pi system. It helps them to, once again, get more consistent product by being able to see the data that's being generated from the process. Regulatory compliance for EPA, FDA, possibly OSHA, and other regulatory agencies. You know, the data's there, so people use it for reporting and compliance. And environmental health and safety, which is a pretty good use case with the sensor, the gas sensor data from the NexVu system. So yeah, poll time. If you can just take a minute and reply to the poll. It should have popped up on your screen, so please go ahead and take a second to answer that. And while you're doing that, I'd just like to mention that at OSIsoft, we believe that people with data can transform their worlds. So we provide people with data, we provide them with the tools to make sense of the data and to share it out with other systems. And we see many of our customers having astonishing digital transformations. Uh-oh, I've just changed, just a second. Okay, sorry about that. Looks like we've got some animations going on here. All right, so the Pi system, we position it as a data infrastructure. We capture data from your operations. We archive it in the Pi Data Archive. We add context to it to represent asset structures or sensors and how they relate to different pieces of equipment. So we have the context, we have visualization, we have analysis tools, notifications, and we can send that data out to third-party systems for other custom analysis. So how does it work? Well, as I mentioned, that the PI system began in the 1980s. So if you wanted to talk to a control or monitoring system in the 80s, you probably needed to write an interface to a proprietary communication protocol. So we got very good at that, and over the years built up a library of about 450 interfaces to different systems and protocols. More recently, so those interfaces just pull the systems, they get the data, and they send the data to the PI data archive where it's archived. More recently, we've come up with a newer technology called connectors that does everything that an interface does, but it also captures metadata. For example, asset hierarchy, or looking at a piece of equipment and getting the manufacturer, make, serial number. And you could get limits for the optimal or safe operation of equipment. So all these static values, they really enrich the real-time sensor data that's coming through. Now, another way that we collect data, even more recently, is that we enable our partners to have their IoT sensors, gateways, and applications write data to the PI system themselves. That's because there's a proliferation of IoT devices, and at OSIsoft, we can't keep up. You know, we built 450 interfaces over many, many years. Well, it seems that new standards and protocols are developing at about that rate every year. So we allow our partners to enable their devices to write to the PI system, which is exactly what Aegex has done with the NexVu system. So we get the data in the data archive. We have a relational layer called the asset framework, where all that metadata is stored, that allows us to intuitively search and browse the PI system. The asset framework has analytic capabilities that you can build in and automatically perform analysis in real time. There's a specific type of analysis called an event frame that takes place on a specific piece of equipment, and it has a user configurable start event and a user configurable end event. It could be the same condition, or it could be two different conditions. When that event happens, the user can configure what pieces of information they want to get. So for a downtime event, or let's use an environmental excursion, for example, you can have the sensor, the start time, the end time, and you could be capturing things like gas concentration, wind direction, who's the supervisor on shift to contact, and so forth. And then notifications on event, you can deliver a notification to configured people or directly to other systems. We also have our native visualization tools. We can replicate data from one PI system to another through the cloud without allowing different stakeholders to access the network of the producer of that data. We can push data out to other systems like S3 ArcGIS, so you can see the data in a geospatial context, and we can send it to a lot of big data systems in the cloud. We also have a series of developer technologies which allow custom applications to pull data from the PI system. So, moving on. For this scenario that we're talking about today, we got an example data flow, and it could start with a NexVu sensor system that's installed in a plant, or it could be portable, and that's generating sensor data from ambient gases, weather, and other ambient conditions. And at the moment, it's sending them to the cloud, whether that's the NexVu cloud or other cloud services. And the NexVu cloud is then sending that data onto the PI server. So we're getting the ambient conditions sent to PI. Using the Aegex 10 intrinsically safe tablet, you could have a connected worker out in the field who's using Pi manual logger to do operator rounds and manually enter data. You could also use other applications on that tablet to manually enter data and send it directly to the Pi system. And if you have a Pi system, there's a pretty good chance that you're already monitoring process data from PLC, DCS, SCADA, or whatever other controller monitoring system. So we bring all these data sources together. We store it in the Pi data archive and add analysis to it from the asset framework, and then push the data back out through through Pi Vision, which is on a web server, where that connected worker with the Aegex 10 intrinsically safe tablet in the hazardous area can now see the data that's being generated all around him. And we're going to have Keven just tell you a little bit more about the intrinsically safe tablet.
Oh, sure. Thanks, Sean. Yeah, the Aegex 10 intrinsically safe tablet, they're purpose-built and certified for Class 1, Division 1, or ATEX or IACX Zone 1 hazardous areas where they won't cause a spark that could potentially ignite a highly combustible environment. So the mobile workers in these hazardous environments can access this data coming from NexVu and connected legacy sensors on the Aegex tablets using OSIsoft's web-based graphical user interface, Pi Vision. The Pi manual logger or other apps like photos, scanning, etc., can also be used on the Aegex 10 tablet to manually collect data. And then this data can be used alongside the automatically collected data from NexVu to get even more insight into a hazardous environment.
Thank you, Keven. So we're going to look at a few use cases very quickly here, and we'll just move on to the next slide. In this example, we simply got a representation of a plant, in this case an oil rig, but it could be any plant. And we've superimposed data from NexVu, in this case, hydrogen sulfide sensors, onto different areas of the plant. This is completely simulated in this case, but so we're showing the actual concentration on the sensors, and we're representing that concentration with different colors that are animated with respect to the actual value in relation to some pre-configured thresholds that can be delivered by the Aegex tablet to say whether you're in a normal state, a warning, or an alarm state. And so just by looking at the color of these sensors, you can get an intuitive view of the shape and concentration of a plume of gas. We've also added the wind direction on here. Once again, this is all simulated, but this is showing the direction from which the wind is coming, which is in line with the direction of the plume. But for somebody who needs to get away from the plume, they know to move at 90 degrees to the wind and get to a safe area. So this is very simple. It's taking the real-time data from Aegex, and it's simply adding some color animations and a location to that data and delivered in Pi Vision. A next use case might be to help identify that there is a leak, the location, and what to do about it, and perhaps what caused it. So we're looking at a process diagram that's coming from the DCS, and we've got a little trend here that might represent the ambient gas coming from an Aegex NexVu sensor. And we might see the orange line of ambient gas concentration rising in relation to a process value, which could be a pressure in a vessel or a pipe falling. So using the process data in conjunction with the NexVu data, we can visually see when something's wrong, but we can also configure rules in the Pi system to notify when one of these conditions is taking place and be much more proactive about if we have to close a valve or evacuate an area before you reach concentrations that are hazardous or dangerous to health. I guess those are both hazards. Also, the PI system has historical data that would allow you to mine it and find the root cause of that leak and take actions to improve the process and process safety so that these conditions don't happen again. We're moving on to another example where we've got a few graphics taken from a NexVu cloud display with all of the sensors in a NexVu array. So this is showing pretty intuitive, showing that everything seems to be in the middle of the range except the H2, which is low. But you could also animate the color based on the thresholds that are being provided from that sensor system for normal hazard, normal warning and alarm thresholds that the sensor delivers, and it delivers them to the PI system. However, you're only looking at a real-time view. So what if you wanted to see what has happened and what may happen? So looking at that data, once again, a simulation, the blue line represents gas concentration over time. This is a one-day example. The orange line represents a warning threshold from a NexVu sensor, and the red line, the alarm threshold. So you can see over time that, you can see if you're approaching a threshold, but over a longer period, you might be interested in seeing how many times has this blue line exceeded the orange line, and how much aggregated time has it spent over that limit. So we can take this information and break it down. So in the PI system, we're doing a count this is a one-day period from yesterday to today, and intervals of 1 hour. For each hour, how many times did that blue line cross the threshold? And for each hour, what's the aggregate number of minutes in this case that the blue line spent above that threshold? You could use this information to trend those results on a longer period and see that if you're trending towards more and more incidents of exceeding that near miss threshold, or more and more time above it, which would indicate that you're heading towards an alarm limit and a reportable incident. So having this data in the PI system, having the history over what might be a long period of time, it might be a year that you want to look at, that can help you to take action to mitigate the conditions that are leading to a reportable incident. So I'd like to wrap it up, and then we're going to get into some questions. So in conclusion, NexVu captures real-time contextual data in hazardous environments. The PI system collects, organizes, and analyzes that data. And then we use PI Vision on NexVu tablets to visualize that data, once again, in the hazardous environment. So all personnel in the areas of oil and gas operations or other hazardous areas are now connected workers and informed about what's going on all around them. Other use cases can also be addressed, like condition-based maintenance, preventive maintenance, predictive maintenance, using NexVu sensors and the PI system. And a few last words, I think, from Kevin and Lee, and then we'll have questions. Thank you.
Thanks, John. So NexVu developer kits are now available for testing. You can order one to set up and begin testing with your back office systems and operational data. PI system demos are also available, so you can test the power of both of these solutions together. Just contact Aegex or someone at Aegex, or reach out to John at OSIsoft. Thanks.
Okay, thank you both. We have a few more minutes for questions from the audience. So if you have a question, please type it into the questions section that you'll see on your control panel. And if we don't get to you right now, then we can answer you directly in an email after this. Okay, so the first question is for John. John, you mentioned the PI system is doing analytics. Can you be a little more specific about what type of analytics?
Sure. Yeah, the PI system collects all that data, and then the asset framework analytics allow you to configure rules, which are pretty simple math. A arithmetic and algebra, it's quite flexible, and you can iterate those calculations. So you can come up with some pretty powerful calculations. But if you're looking for machine learning, advanced pattern recognition, AI, these types of things, the Pi system is a great source for those type of analytics. But I think it's important to think about what kind of analysis you want to do and where's the appropriate place to do it. Jumping way ahead to machine learning or AI might not be the best first step. Start with things that are simple and easily achievable.
Okay, terrific. So if there are no more questions right at the moment, we can always answer you directly via email. So please do get in touch with either John or Keven. And we thank you so much for joining today. Don't forget to look for the follow-up email that has a survey in it, as well as a recording of this webinar and a handout. So thank you again, and have a nice day. Goodbye.